Hoisting in JavaScript is a mechanism where variable and function declarations are conceptually moved to the top of their containing scope during the compilation phase. This process happens before the code execution begins. It's important to note that only declarations are hoisted, not initializations or assignments. Physically, the code does not move. Instead, hoisting is a conceptual model that explains JavaScript's behavior. JavaScript's execution process consists of two main phases: the creation or compilation phase and the execution phase. During the creation phase, JavaScript allocates memory for variables and functions, and this is when hoisting occurs. The execution phase then runs the code line by line. Function declarations are fully hoisted, meaning both the function name and its body are available throughout their entire scope. This allows you to call a function before it appears in the code. For example, calling a function like, say hello, before its declaration works perfectly fine. However, nested function declarations are only hoisted within their containing function. Additionally, when a function declaration and a variable declaration share the same name, the function declaration takes precedence. On the other hand, function expressions behave differently. Only the variable declaration is hoisted, not the function assignment. For instance, attempting to call a function expression before its assignment results in an error because a variable is initialized as undefined until the assignment is reached. Arrow functions follow the same hoisting rules as function expressions. Variables declared with var are also hoisted, but only their declarations, not their initializations. These variables are initialized with undefined until their assignment is executed. For example, logging a var variable before its assignment will return undefined rather than throwing a reference error. Additionally, var variables are scoped to functions or globally, not to blocks, and multiple declarations of the same var variable are merged. In contrast, variables declared with let and const are technically hoisted but remain in a temporal dead zone, or TDZ, until their declaration line is executed. Accessing these variables before their declaration results in a reference error. This behavior makes let and const more predictable compared to var. Unlike var, multiple declarations of the same let or const variable are not allowed, further enhancing code reliability. In JavaScript, declarations of the same identifier using let or const result in a syntax error. This is because let and const have block scope, meaning hoisting only occurs within their containing block. Similarly, classes are hoisted like let and const declarations. However, they exist in the temporal dead zone, or TDZ, until the declaration is reached. For example, attempting to instantiate a class before its declaration will result in a reference error. Both class declarations and class expressions follow this pattern, and static methods or properties are also inaccessible before the class declaration. The temporal dead zone, or TDZ, is the period between entering a scope and the actual variable declaration. During this time, variables exist but cannot be accessed. Attempting to access them results in a type error, not a reference error. The TDZ applies to let, const, and class declarations. This mechanism enforces cleaner code by requiring variables to be declared before use, helping catch potential issues early by throwing errors. Hoisting behavior varies depending on the scope. In the global scope, declarations are hoisted to the top of the global context. In function scope, declarations are hoisted to the top of the function. For block scope, let and const declarations are hoisted to the top of the block. Nested scopes follow the same hoisting rules within their respective boundaries. Shadowing can occur when a variable in an inner scope has the same name as one in an outer scope, effectively hiding the outer variable. Function parameters are unique in that they are already in scope at the start of the function. They act as local variables defined at the top of the function. However, redeclaring parameters within a function using var can lead to unusual behavior. As the parameter is redefined, using let or const to redeclare parameters, on the other hand, causes a syntax error. JavaScript module imports are hoisted, meaning you can use imported values before the import statement in your code. This behavior differs from common JS require, which is not hoisted. To avoid issues related to hoisting, follow best practices such as declaring variables at the top of their scope, using let and const instead of var, and adhering to a declaration before use pattern. Prefer function expressions over function declarations when appropriate, and maintain consistency in your declaration styles. Finally, understanding the temporal dead zone is crucial when working with let and const. Hoisting in JavaScript can lead to complex scopes and unexpected behaviors. To manage this, use tools like ESLint, which can enforce rules such as declaring variables before they are used. When debugging hoisting issues, browser developer tools are invaluable. You can set breakpoints to observe variable states during execution and examine their scope and values. Adding explicit declarations at the top of your scopes can also improve clarity. It's important to understand the differences in error messages, such as reference error, which indicates a variable is not defined, versus type error, which often points to issues with variable usage. Be cautious of redeclaration issues, especially when function and variable names conflict. Advanced hoisting scenarios include closures, where hoisting follows the same rules but can create intricate behaviors. For example, function hoisting within conditional blocks still hoists the function to the containing scope. Initializing variables with other variables can also lead to unexpected results. For instance, if you declare var x equals y and var y equals 5, logging x will return undefined because y is hoisted but not yet assigned. Variables declared with var in loops are hoisted to the loops containing scope, whereas block-scoped variables declared with let or const get a fresh binding for each iteration, which is particularly important for closures. Modern JavaScript provides tools to mitigate hoisting issues. S modules encourage explicit imports, reducing ambiguity. Strict mode prevents some problematic hoisting cases. And code transpilers may transform your code in ways that affect hoisting behavior. Finally, modern development practices favor the use of let and const, which reduce hoisting-related bugs and improve code reliability.